Right. So in basic organic chemistry, we discussed what is hybridization in organic as well as inorganic molecules, followed by what is linearity, planarity. After linearity, planarity, we discussed about types of carbons, followed by introduction of what is degree of unsaturation. So what is degree of unsaturation? Unsaturation of organic molecule expressed in terms of du. So general formula is if two hydrogens are less than alkane, general formula first degree of unsaturation followed by 4, 6, 8 hydrogens like that. Okay. So one more formula is there for calculating degree of unsaturation, 2n1 plus 2 minus n2 by 2. So based on that will give one number. Based on that number, if it is one double bond or one cyclic ring. Okay, one pi bond generally. Suppose 2 du means one triple bond will be considered because one triple bond carry 2 pi bonds. Like that we can calculate number of structures. So take few more examples to calculate du. C4H2. C4H2. 4 carbons, 2 hydrogens. So N is equal to what? N is equal to 4. Apply alkane general formula. CnH2n plus 2. Here, what about N here? C4. Can I write S10? 2 into 4, 8 plus 2, 10. C4 is 10. So how many hydrogens are differ? So minus 8 hydrogens are differ or not? If I remove 8 hydrogens from here, you will get 2 or not? So now what is the degree of unsaturation? Du is 4 or not? 8 by 2, 4. So otherwise use the formula. What is the formula? Degree of unsaturation is equal to 2n1. What is n1? 2n1 plus 2 minus n2 by 2. This formula I given yesterday. So what is 2n1? 2 into 4. 2 into 4 plus 2 minus, is it 2 or not? By 2. So if you want to apply du formula, use this directly. So 2 into 4, 8 plus 2, 10. 10 minus 2, 8 by 2. 8 by 2 means what? So 8 by 2 means 4. Okay. So here we can write 4 carbons. Write down 4 carbons. Now I want to create du first. So I can put a triple bond here and one more triple bond here. Is it du matching? Du for 4 carbons are also matching. Here one hydrogen and here one more hydrogen. That's it. So can I write rings with 4 carbons? So you can also write a ring. If it is possible, we can write. So here 4 carbons are present. 4 carbons. Okay. 1 du or not? 1 du. And if I write one double bond, 2 du. Okay. And if I write one more triple bond here, 3 and 4. So here one hydrogen, here one hydrogen. So if you consider number of carbons and du, you can create many structures. Clear? Right. C5H6. What is the du of C5H6? You can use even this formula directly. How much? Degree of unsaturation 3. C. Degree of unsaturation 2 into 5. 2 into 5 plus 2 minus 6 by 2. So what you will get? You will get 3. Right? 10 plus 2, 12 minus 6, 6 by 2, 3. 3 means, can I write all open chain? 1, 2, 3, 4, 5. I want to create degree of unsaturation 3 means 1, 2, 3. Matching? At least one example you need to create. You can write double bonds also, if possible. So, one open chain, one ring. See, I am going to write one 5-member ring. 5-member ring, double bond. Possible? Can I write 6-member ring? No, because maximum how many carbons? 5 carbons only. You can create a shorter rings but not larger rings. So, can I create a 4-member ring? Yes, 4-member ring. Outside I can write one carbon. Okay, so I can put one double bond outside and I can put one more double bond inside. So 1, 2, 3. Du is 3. Matching. Then no need to see hydrogens, automatically hydrogens will follow. Here 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. If you see Du and number of carbons, no need to see hydrogens. Hydrogens automatically it will follow. See here. 2 plus 1, 3. 3 plus 3, 6. 1, 2, 3, 4, 5, 6. Like that. See, suppose if any halogen is present, every halogen just add one hydrogen. In your mind you remember these points. Suppose in this I given only hydrocarbons, only carbon, hydrogen I given. I not given halogens, I not given oxygen, nitrogen, other elements are not given. Okay, so because organic molecules also carry heteroatoms. Suppose if other than hydrogen is present, if any chlorine, bromine, nitrogen, oxygen is present, how to calculate? Okay, every halogen, it may be fluorine, chlorine, bromine, iodine, just assume that one hydrogen in that formula. Okay, so this you need to remember. Then every oxygen doesn't affect hydrogens. No need to remove, no need to add. Every oxygen. And suppose every nitrogen, try to remove one hydrogen, minus one hydrogen. You remember this formula? If you want to calculate degree of unsaturation, if any organic molecule having halogen, every halogen assume that one hydrogen. Every nitrogen, remove one hydrogen. Actually we are not removing. To calculate Du, we are removing. In order to calculate Du, we are assuming in mind. But later on, while writing structure, you need to write the same atoms. So I will show one example, you will understand clearly. See, C4H6Cl2. So here halogen is there or not? Every halogen, what should I do now? Every halogen add one hydrogen. That is in your mind. In your mind you need to think like this. So here two chlorines are there. I want to add two hydrogens to this formula. If I add two hydrogens, what is your general expected formula? C4H8. This you need to assume in your mind only. It is not real. To calculate Du, we are using only hydrocarbon formula or not? 2N1 plus 2 minus N2 by 2. Is there any halogen here? No, only hydrogen is there. Only carbon is there. So in order to convert hydrocarbon, I am assuming that every halogen is equal to one hydrogen. So you will get C4H8. With this we need to calculate Du. So what about du here now? Degree of unsaturation 2 into 4. You apply this formula like this, double this number. So if you double 4, you will get 8. 8 plus 2, 10. 10 minus 8, 2. 2 by 2, 1. So du is 1. Indirectly I am applying this formula only. Every time double this number, add plus 2, then remove this number, then divide by 2, you will get the answer. So degree of unsaturation 1 means what? 1 double 1. See, after getting du, we need to add halogens in this molecule. This is only analysis, it is not real molecule. So what should I do now? So I can write 4 carbons, 1, 2, 3, 4. Can I write 2 halogens or not? First you write down halogens anywhere, your wish, you can add anywhere. Then write down du. Du means I can write double bond anywhere else. Then balance with hydrogen. Here can I balance hydrogens? Is it CH2? And it is hydrogen. And here also hydrogen. And here also 2 hydrogens. Is it matching? C4, 1, 2, 3, 4, 5, 6, 2 chlorines. That's it. Like that. Clear? So just you calculate this with 2 halogens. C2H2Cl2. What is the du? What is the structure? At least one structure. C3H2Cl2. C6H4Cl2. At least one structure you need to create. So what is your assumed formula? What is assumed formula? C2, it is assumed formula. It is not real. To calculate du, we are creating this one. Clear? And here also. What is the formula? C3, H4 or not? And what about this? C6, H6. Every time we are adding hydrogens. So what about du? Degree of unsaturation 1 or not? So if it is 1, first you write down 2 carbons, then write down 2 chlorines, then create du. So I am putting double bond here, no other option. Then here add 1 hydrogen, here add 1 hydrogen, that's it. Other than hydrogen first. Now what about du? C3H4. du 2 or not? Degree of unsaturation, is it 2? Double the number, 6. 6 plus 2, 8. 8 minus 4. 8 minus 4 what? 4. 4 by 2, 2. Apply 2 n1 plus 2 minus n2 by 2 formula. Is it clear? Now du2 means what? How many carbons are given? 3 carbons. Here 1, 2, 3. Here 2 chlorines are there. You can write 2 chlorines anywhere else. du if you want to match. Here put one double bond, du matching, 2 is over. Then here I can write one hydrogen, here also one hydrogen, that's it. You can put triple bond also. You can put a ring also, your wish. Ring, one double bond. 3 membered, one ring, one double bond. Like that. You can create many structures. See, this is 3 carbons. Du is how much? 1. 1 or not? So if I put a double bond here, du 2. 2 is over, du matching. Then here put one chlorine, here put one chlorine. Then here no hydrogen, no hydrogen. Here 2 hydrogens. So that is 2 hydrogens. See, after calculating du, forget about this formula. Don't think about this formula. This formula only to calculate du. Once if you know du, then go through this molecule. 3 carbons, 2 hydrogens, 2 chlorine. First write down 3 carbons, then write down 2 chlorines, then see how much du is present. Write down du. Enough. Automatically hydrogens will follow. Clear? Don't search for hydrogen. Search for first carbon, then du, then other than hydrogen. Then at last see hydrogens will follow. Forget about hydrogens while writing structure. What about du here? C6H6 already well known. Du is 4. So now du is calculated for this one. This du belongs to either C6H6 or this C6H4Cl2. C6H4Cl2. Okay, du is 4. So can I write benzene? 6 carbons, benzene, write 2 chlorines. Anywhere you can write 2 chlorines. Any structure you can create. 6 membered, 5 membered, 4 membered, 3 membered, open chain. Many structures are possible. C3H7N. Nitrogen is there. First create only hydrocarbon formula. After creating hydrocarbon formula, then you can calculate du with respect to du formula. Every hydrogen, can I remove every nitrogen is equal to minus 1 hydrogen? See how many nitrogens are present? 1. So can I remove 1 hydrogen? Then what is the formula? C3H6. Then calculate du for this formula. du is equal to double the number 6. 6 plus 2? 8 minus 6? 2 by 2? 1. Now du is over. Once if du is over, then apply the du to this one. How many carbons? 3 carbons, 1 nitrogen. Then write down du. How much du? 1. Means I can put double bond anywhere. Suppose if I put double bond here, then see the hydrogens. Here how many should I write? 2 hydrogens, 1 hydrogen. Here 2 hydrogen, here also 2. Because nitrogen is a trivalent. See the formula? C3H7. 2, 3, 4, 5, 6, 7. Matching or not? You take any one, definitely will matches. C2H3N. C3H3N. C2H2N2. C2H2N2. What about du? How to calculate C? C2 H2 or not first? Remove one hydrogen. And here, can I remove C3 H2? And here, how many hydrogens should I remove? C2. Can I remove two hydrogens? Two hydrogens or not? See, every nitrogen minus one hydrogen. To calculate du. Okay? Now calculate du for this. What is the du for this? Is it 2 or not? Very easy. Degree of unsaturation 2. 2 means outright. 2 carbons, then 1 nitrogen. Right or not? So, can I put triple bond? You can put triple bond and here 1 hydrogen, here 2 hydrogen. Yes. You can put carbon nitrogen triple bond also. This carbon nitrogen triple bond you can write. Otherwise, carbon nitrogen double bond, carbon nitrogen, carbon carbon double bond also possible. How many pi bonds we need to create? 2. Can I create one ring? Yes. So, this is one more example. 2 carbons, 1 nitrogen I am writing. Du is how much? Now it is 2, but right now it is only 1. So, put double bond and here 1 hydrogen. So, C2H3N. C2H3N. Azirine. What about C3NH2? So what about du? Degree of unsaturation is 3 or not? 8 minus 2, 6 by 2, 3. One structure, at least one structure. 2 double bonds, 1 ring possible? 2 double bonds, 1 ring. C. You can create a structure like this. Here 3 carbons are over, here 1 nitrogen. Total 3 carbons, 1 nitrogen. 3 carbons, 1 nitrogen. du is 3. 1, 2, 3 over. That is the specialty of this concept. So what about this? du? Hydrogens are 0 or not? No need to add hydrogens here. Just calculate du. du is equal to how much? That is 3. So molecule is almost all same. Here nitrogen, nitrogen. Here double bond, double bond. C4H5N. C4H5N. C5H5N. Just calculate du of these examples and create one structure. C4H4 into C3N3N3 C3H3N3. See, every time nitrogens are coming, it will be helpful for mass spectrometry. Nitrogen role. This is nitrogen role only. What about du? Is it 3 or not? 3. So can I create one structure? Pyrrole. What about du? Is it 4? 4 means I can create one structure. Pyridine. Now 2 nitrogens are there. What about du? C4H4. Is it 4? Yes, du is 4. So diazerine. Ine in ane you will get for 2 nitrogens. Diazine 1 comma 2. Now we have 3 nitrogens. What about Du? C3H3N3. 3 or 4? How much? 4, not 3. 3 nitrogens, remove 3 hydrogens. You will get only C3. Double the carbon number. 6. 6 plus 2, 8. 8 by 2, 4. Don't add this 3. Because you need to assume like this. See, if you assume like this, what is the formula? C3 only. That is the problem. If you don't know this creativity, it is impossible to determine the structure of organic molecules. So now Du is 4. Then molecule carry 3 nitrogens like this. See, this is nitrogen, double bond, double bond, double bond. That is the answer. C2H6O. C2H4O. Now, when oxygen is present, what is the strategy? We should not add any hydrogen, we should not remove any hydrogen. So, on that case, just write down the formula what you have. C2H6. And here, what is the formula? C2H4. What about Du for C2H6? Du is 0. Calculate. See. 2 into 2, 4. 4 plus 2, 6. 6 minus 6, 0. So 0 means, is it saturate or unsaturated? Saturate. Saturate like that. So here you write 3 hydrogens, here 1 hydrogen, and this is OH. What about Du? Du is 1. So Du is 1. One structure we can create. So see, carbon, carbon, oxygen, right? Put one double bond anywhere, your wish. So I can put double bond here. Then here balance with 3 hydrogens, here 1 hydrogen. Acetaldehyde. You can create alcohol also, vinyl alcohol. C4H4O. C6H4O2. C6H6O. C7H6O. Out of all basics, this is most expected for your CSR examination, especially for spectra. If you want to attempt any spectra questions, so some basic knowledge is required. Suppose if they given only molecular formula, and if you want to determine the structure, on that time mass spectrometry, nitrogen rule will play an important role. So it will comes one more time in mass spectrometry, but same concept is remain same. Will you calculate this? Simple, directly remove oxygen, consider only carbon, hydrogen. You will get the answer. Create at least one structure. What about DU here? DU 3 or not? 3. C6H4O2. Six carbons, 4 hydrogens, 2 oxygens. How much? DU is 5. Create one structure, at least one structure. What about DU? DU 4. And here DU, that is 5. So this I am writing DU5. Is it possible? Quinone. Like that. Give degree of unsaturation for following molecules. I am going to give some molecules. That molecules DU you need to write by watching the structure. Give degree of unsaturation of following molecule. give degree of unsaturation for following molecules. So what is du for this? So this is du, you write down. Du column. This is a molecule. What is du? Is it 3 or not? Yes, very easily you can pick the answer. 1, 2, 3. Suppose if I take this molecule, double bond, like this. What about du? 1, 2, 3. Very easy. 3. What about du? Very easy. Just counting rings and double bonds. 1, 2, 3, 4. So du is 4. Clear? Only double bonds, only rings if you consider. That is sufficient. See. How many pi bonds? 1 pi bond. How many ring? 1 ring. Pi bond, 1 ring. Pi bond, 1 ring. Like that. This is du number. This is the molecules. More unsaturation, more du, more unstable. Not every time. Depends upon molecule also sometimes. Because sometimes conjugation helps to delocalize, that will increase the stability. On that time we can't apply that statement. Okay? But generally, when you write any molecule with a higher du, it becomes highly stable if they carry more number of rings normally. But when you write any conjugations continuously, it becomes stable. Clear? What is du for this? Suppose if you are unable to determine du, count carbons, count hydrogens, write down carbon, hydrogen, apply du formula, then you confirm it like that. How much du? How many carbons are there? 7 carbons. 7 carbons there or not? 1, 2, 3, 4, 5, 6, 7. 7 carbons. 7 carbons, how many hydrogens? By watching molecule, you are in a position to say how many carbons, how many hydrogens, how many other than carbon, hydrogen within the molecule. You should be in fast. 7 carbons or not? 7 carbons. How many hydrogens? Here how many hydrogen? 1, 1, 1, 1, 1, 1. Here 2. How it is 3? 2 only. This carbon having 2 hydrogens. 8 hydrogens. Without du formula, how to calculate? Left side 1 double bond, right side 1 double bond, left side 1 ring, right side 1 ring. Total 4. 4 or not? du 4. So suppose if you apply the formula, is it C7? C7 how much hydrogens? 8. Double this number. 14. 14 plus 2. 16. 16 minus 8. 16 minus 8. 8 or not? 8 by 2. 4. That is a way of calculation. Every time they won't give molecular formula. Sometimes direct molecule they will give. And they will ask du. Especially bicyclic compounds. When bicyclic compounds are given, we don't know how many rings are there. Okay? Not easy to identify because I am mentioning it is a bicycle. We'll work out this. So take down these all examples, work out later. So that is about du. Clear? So take down these molecules, work out later. Okay? So problem with bicycle, tricyclics only, but normal rings are very easy to find out. Suppose if you are getting any problem, count carbons, count hydrogens, apply in that normal general formula. That will give direct answer. Okay? So directly this concept is not helpful, indirectly it is helpful. Right. So that is about du. Next. Calculation of sigma and pi bonds. How to calculate sigma bonds and pi bonds in a given molecule. Calculation of sigma and pi bonds. First, calculation of sigma bonds for variable molecules. Then I will show how to calculate pi bonds. Calculation of sigma bonds. Suppose if I take alkane, remember number of carbons multiplied by 3 plus 1. This is the formula. Alkane. If any alkane is given, you need to find out like this. Suppose if I give ethane, how many sigma bonds are present? Number of carbons, how many are there? 2. 2 into 3. Number of carbons multiply with 3. Here 2 carbons are there. 2 into 3 plus 1. Total how many? 7 sigma bonds. Okay. Suppose if I give pentane, is it pentane or not? How many carbons are present? 5 carbons. 5 into 3 plus 1. Like that. 15 plus 1, 16 sigma bonds. Okay. Suppose if I say decane. Decane means how many carbons? 10 carbons. 10 saturated carbons or not? Ane. Ane means saturate. Saturate means 10. 10 into 3 plus 1. Is it 31 sigma? Okay. So, based on the number and name you need to identify. Hectane. Hectane means how many carbons? Hectane. Not heptane. Heptane means 7. Hectane. What about 10 carbons? Decane. Level carbon, undecane. 12 carbon, dodecane. Okay. 20 carbons, ecose. Ecosane, henicose, like that. Okay. 30 carbons, triacont, tetraacont, pentaacont, hexaacont. Bulkminster fullerene, Sagar ball, buckyball, many names are there. C60. Okay. Heptaacont, octaacont, nonaacont, hectane. 100 is called hectane. 1000 is called killiane. kili, 200 dihect, trihect, 400 tetrahect, pentahect, etc. Root words you remember. In nomenclature I will explain, but right now remember up to 20 I think you are familiar. What is level indicates? Undec, dodec, tridec, tetradec, 19 nonadec, 20 ecos, 21 henicos, like that. Okay, only 20 to 30 little bit names are changes, but remaining all case it is same. What is 30? Tri-econt, tetra-econt, penta-econt. From here onwards up to 90 same. Suddenly 100 comes, 100 is killian. C60 is most important. C60 is bulk minister fullerenes. So this is not our concept, but you need to know whether it is alkane or alkane. So how many carbons are present? 100 carbons. Then how many hydrogens? In alkane, if 100 carbons are present, how many hydrogens are present? What is alkane general formula? CnH2n plus 2. 2 into 100. 200 plus 2. Is it 202 or not? It is 202, like that. Based on hydrogen, we can confirm whether it is alkane or alkane. Every time, double the number, add plus 2. Double the number, leave it, alkene. Double the number, minus 2, alkyne. So how many sigma bonds are present? Number of carbons, 100 multiplied by 3 plus 1. So 300, 301 or not? Okay, so finally 301 sigma bonds. Only one time in CSR examination this question is given to calculate sigma bond. Only one time, and that too old paper, not new papers. Before 2010 old papers are available. In that old papers they ask how to calculate number of sigma bonds question. Only one time that question is given. Almost all more than 15 to 16 years they not even one time they asked about how to calculate sigma and pi. But they are definitely helpful. Suddenly in isomerism, suddenly in any particular stereoisomer relation, it may be helpful. Is it clear? Alkenes. You remember this? Number of carbons multiply with 3 minus 1. Alkene, double bond. Difference between alkane and alkene is here plus 1, minus 1. Here carbon-carbon double bond. Hectane. Will you calculate the answer? See, same. Ane, decane, hectane. Now what I given? Decene, hectane. Will you work out this? How many carbons? 2 into 3 minus 1. And here how many? 5 or not? 5 into 3 minus 1 decane. 10 into 3 minus 1 hectane. 100 into 3 minus 1, like that. Just reduce 2 hydrogens. Here how much you are getting? 7. There you will get 5. 14. 29. And here 299, like that. Same. Because one double bond means we are removing how many hydrogens? 2 hydrogens. That's it. Simple. See, in this, how many atoms are present? How many atoms are present in this one? So you remember this formula. Don't apply. Number of sigma bonds is equal to total number of elemental atoms. Total number of elemental atoms plus 1. Just you keep this point in your mind, but don't apply every time. It cannot match for all. Only for few molecules it is applicable. Total number of elemental atoms. In this, how many atoms are present? Total. 2 carbons, 6 hydrogens. Total how many? 8 or not? Total number of elemental atoms are how much? 8. Okay, so 8 plus 1, 9. Okay, so see, here if I write minus 1, is it matching or not? Total number of elemental atoms minus 1. Sometimes it may be plus 1. That's why I am saying that don't apply this formula. Depends on molecule, maybe changes, but don't apply every time. Now in this one, how many elemental atoms? 6 minus 1. You will get 5 or not? Sometimes it is matches. Sometimes plus 1 we need to apply. That's why this just keep in your mind, but don't apply every time. Sometimes it may changes. That's why I am not using this formula to calculate. Just keep in your mind. To add total number of elements, count elements minus 1. Suppose if it is directly minus 1, I will use this formula directly. Some molecules we need to apply plus 1. Plus 2, minus 2, depends on the skeleton. That's why some heteroatoms will come, some halogens will come. On that time we can't apply this. So this formula is not correct, but maximum molecules you can apply. Be careful, but this is correct formula. Alkane, alkene, alkyne, you can apply. Here how many elements are present? I think counting is too difficult. 1, 2, 3, 4, 5. 5 carbons. 5 into 2. 10 plus 2. Otherwise you count hydrogens first. 3 plus 3. Every time see, whenever if you are counting hydrogens for alkane, first you target terminal. 6. 8, 10, 12. Like that. First terminal. Terminals only. Because 3 into 2. 6. 8, 10, 12. 12 plus 5. 5 carbons. 17. 17 minus 1. You will get 60. But don't believe that formula. Only for few functional groups. Only for selective groups. Only it is applicable. Some books they will write it as plus 1. Don't confuse. That may not be applicable for this molecule. But some other molecules it may be applicable. Clear? Is it over? So what is the formula to calculate alkene number of sigma bonds? Number of carbons multiplied with 3 minus 1. Alkane plus 1. This is alkyne. Number of carbons multiply with 3 minus 3. Alkyne. So here carbon carbon triple bond I am writing, just count the answer. Here carbon carbon triple bond, decyne, hectyne. Just use this formula and say the answer. Cycloalkane, number of carbons multiply with 3. Will you work out this? 2 more we need to remove. See, for alkene, what is the formula? Alkene, what is number of carbons multiply with 3 minus 1. Now here minus 3. How many carbons? 2 into 3, 6. 6 minus 3. 3 sigma. Right or not? 2 into 3 minus 3. Here. 5 into 3 minus 3. Decyne. 10 or not? 10 into 3 minus 3. And here 100 into 3 minus 3. We are removing 2 more hydrogens from double bond or not? See how much you are getting in double bond? This molecule. Suppose if I put double bond, how much you are getting? 5 or not? So remove 2 more. 3. Simple. Alkane 7, 5, 3. See the strategy. Means if you want to create any pi bond, how many hydrogens should I remove? 2. If I remove 2, 7 becomes 5. If I remove 2, 5 become 3. Like that. Simple. You need to observe these all things. Not only formula. Observation is most important. Organic required more observation, more usage of mind, presence of mind, activeness of mind. That is sufficient. No need to revise next time. If you think that after completion of syllabus, if you want to prepare at a time, it is impossible. Don't make such type of plannings for preparation of CSR. Prepare parallelly. Don't try to make your mind to allow postpone a topic. Today if any topic is started, try to focus on that day only. Don't give any excuse for organic, especially organic. Because once if topic is over, that will be postponed only. You won't open, you won't read. It will be keep on extending. You will think that tomorrow I will revise, day after tomorrow, 3 days, 4 days, 5 days. Finally it will be over. You won't open, you won't read. That is the problem with organic. That's why don't allow your mind to think about organic for postponing any concept. Simply whenever if you want to revise, directly you follow. And don't try to make any plannings to prepare. Frankly I am saying, suppose if you want to prepare organic chemistry or any chemistry at 4 o'clock or 5 o'clock early morning, it won't work. Because you will wake up 5 to 5:05 sharp. Alarm will ring at 5 o'clock, but you will make up and you will wake up and you will make them into 5:05 sharp. 5 minutes you want to take break. Possible? No. Then later on 5:05 to 5:10. 5:10 to 5:15. Regular it will repeat. Finally it is continuously repeating. You people also continuously repeats. You won't sleep, you won't read. Okay? So whenever if your friend is reading, don't surround around them. Don't keep moving outside. Don't go other places. Simply sit there. Ask them what you are reading. Explain. You ask them. Okay? So don't think that your friend is reading and you want to read it secretly 3 o'clock, 4 o'clock like that. That won't work. Don't make such type of plannings. Organic required more discussion. Then it will be fixed in your mind. Suppose secretly if you are opening a book, okay, in your mobile torch light you are open and you are reading secretly, means it will be secret in your mind also. It won't come. In examination it won't come. It is a secret. You are learning secretly or not? You are learning subject secretly. That's why it is also secret in your mind. Question will come in exam, that won't come. Because it is secret. That's why don't play with chemistry. Not only organic, don't play with chemistry. Try to share. First you try to share. Suppose if your friend is not listening, catch them, say to sit, try to explain. Two benefits will be there. Topic will be permanently fit in your mind. You won't get any confusion first of all. If you are not facing the concepts clearly, not expressing, not writing, read once, write once, sufficient. One time writing is almost all equal to 1,000 times reading. If you write one time, you will get more confidence than 1,000 times reading. Slowly, your writing ability will be decreases. Finally, one time reading equal to one time remembering. That will be developed slowly. Okay, you need to know the art of preparing organic chemistry, inorganic as well as physical. Three are different. You try to maintain three different strategies based on your standards, based on your mind ability. First, you know about your mind. Don't compare your friend mind. First, know about your mind. How your mind is receiving the concept. Whether you are able to understand or not. Why you are not able to understand. Why you are not recollecting. Why you are unable to recollect very fastly. What is the problem? Search for that. Based on that, you try to prepare. Your friend prepared one particular strategy. Don't follow that strategy. Because based on his mind, he was prepared one strategy. If you follow, you will lose. Some people will be there. One time if they read, they will prepare. It will be there permanently in their mind. Same way if you prepare, that is foolishness only. Because you need to know about your mind first. Clear? Based on that, you need to prepare for examination. My suggestion for each and every student is, try to prepare parallelly. Suppose topic is over, try to spend 2 minutes every day for completed topics. Because at a time if you want to prepare, it will take much more time. Every day try to spend minimum half an hour. Suppose if 2 months, 3 months, 4 months is over, minimum half an hour I am saying. Minimum half an hour for completed topics. Slowly go through 1 hour. Minimum 1 hour for completed topics only. You need to stay, keep opening your organic, inorganic and physical notes. See the topic, close and think once. What do you know about that one? First you say, what I know. Don't think about questions. First of all, this is the topic, what I know. Just ask question yourself. Degree of unsaturation, what I know. Only that point will be permanent in your mind. Like that you need to prepare. Clear? What is linearity, what is planarity? What I know. Just think yourself. Ask question yourself. First you know about the concept and confirm how much your mind is able to remember. Check your mind standards. How much your mind is supporting. In which way if you prepare, your mind is going to support. On that way you need to prepare. Some people only one time if they revise, they can remember. Some people after revising, they need to write. Then only it will be remembered. Some people, they need to read continuously. 3 to 4 hours they will read continuously. Suppose still if your mind is not supposed to work clearly, try to change the strategy. Means keep on changing the strategy so that your mind will fix at one particular place. So that strategy you need to apply for the ongoing concepts or already prepared concepts. So you can recollect very fastly. Because in examination, many chapters you need to recollect. It is not easy on that time. One formula to other, if you keep on shuffling, that may be a biggest headache for you. Clear? Right. So cycloalkane, suppose if I take cyclohexane, how many carbons? 6 into 3. How many? 18 sigma. Suppose if it is a pentane, how many carbons? 5 into 3. It is 15 sigma bonds. Like that. Here see, if I take benzene, number of carbons multiply with 2. Benzene, number of carbons multiply with 2. So benzene carry how many carbons? 6 carbons. 6 into 2. How many sigma bonds? 12 sigma. Twelve is most important for benzene. Benzene with hydrogen, without hydrogen, sigma bond is must here. With hydrogen, without hydrogen, here one sigma bond is left. So with respect to that, if I connect any carbon or any other element, sigma bond is appeared. Naphthalene. Number of carbons multiply with 2 minus 1. Anthracene. Number of carbons multiply with 2 minus 2. Naphthalene, NaPH, not NaPTH, NaPH, naphthalene, number of carbons multiply with 2 into 1. How many? How many carbons are present in naphthalene? 10 or not? So I can say 10 into 2 minus 1. How many? Now here. 14 or not? 14 into 2 minus 2. 26. So this is one more to calculate. Calculation of pi bonds. How to calculate pi bonds in a given molecule. Calculation of pi bonds. This is not applicable for rings. Only for open chain it is possible. Formula for only open chain. If I give any molecular formula, apply only for open chain, don't apply for rings. Okay, so this formula already revealed. Number of pi bonds is equal to 2n1 plus 2 minus n2 by 2. This is the formula. number of pi bonds is equal to 2n1 plus 2 minus n2 by 2. Clear? Suppose C4H4 I given, H8, C4H8. So how to calculate number of pi bonds in this one? Is it 2 into 4? 2 into 4 plus 2 minus 8 by 2. How much you'll get? 10 minus 8 by 2. 2 by 2, 1. So they carry how many pi bonds? 1 pi bond. 1 pi bond means, can I write 4 carbon with 1 pi bond? 4 carbons, 1 pi bond. You can write anywhere. Right? 4 carbons with 1 pi. C4H6. C4H6 carry how many pi bonds? Two into 4 plus 2 minus 6 by 2. So how much you will get? 2 pi. 2 pi means 4 carbons. 4 carbons, 2 pi. This is 1 pi, here 1 more pi. Like that. This is maximum pi's I am saying. How many maximum pi's you can create for this molecular formula? Don't compare du. Okay, this formula maybe belongs to du, but same formula also calculates how many maximum number of pi bonds you can create with this formula. With this formula, how many maximum pi bonds you can create? That is the question. Maximum pi bonds, not rings. Clear? This is a formula only for calculating pi bonds for open chain, not for rings. C3H6. C6H6. Right, C3H4 you write better, because very easy to calculate. C3H6 also possible, but no use, same, this concept you will get. You better write C3H4. If you are already written, you take one more example as C3H4. Don't cross out, just make them clear. Double the carbon number. 2 into 3, 6, 6 plus 2, 8, 8 minus 4 by 2. 8 minus 4, 4 by 2 means 2 pi or not? 2 pi. How many carbons are present? 3 carbons. So can I put one triple bond? How many pi bonds present in triple bond? 2 pi. With this molecular formula, question is C. With this molecular formula, how many maximum pi bonds you can calculate? That is this formula. Maximum. Clear? Now C6H6. What is C6H6? I think at least in last before class you can say C6H6 means benzene. But right now, you are not saying. Okay, I think you understood something. C6H6 is not benzene. Remember. Okay. So what is your surname? Every person having one surname. Suppose see whether if they call you by your surname, will you respond? Occasionally. Because many people having same surname. Suppose in one class one surname is there. I am not going to ask them to stand based on their names. I say based on their surname. So 10 people are there, 10 people having same surname. Okay. So based on surnames, if you give nomenclature, that is called Relative configuration. DL configuration is relative. It is coming from history. You don't know your history of your surname. Do you know? No. Then why you are accepting that one? Right or not? You don't know your surname history. Then why you are accepting? You should know something about your surname or not. Ask your parents. You better you ask and make a clarity. They won't say. They will say, I don't know. My father say to follow. That's why I'm blindly following. You ask them. They also say the same thing. That's why previous history. Blindly we need to follow. No more questions. That is called relative configuration. Coming from history. Big history will be there. No one knows. Clearly. My surname is Pogaku. Why? Do you know what is the meaning of Pogaku in Telugu? In English, tobacco. That surname actual meaning, if you want to convert in English, put tobacco. Any meaning is there? So you won't sit if many people's surnames, if I say clearly in their proper language. Okay? Big history will be there. That history we don't want. Okay? Anyone, if they laugh based on your surname, simply ignore it. No more questions. Because simply say only one thing. We are following from the history. Okay? That history we are following blindly. Without any questions. So your children and your parents, what it may be, they need to follow the same thing. It is the biggest history whose history cannot be known. You don't know your grandparent names also, but we are following their surnames. Fourth generation parent, do you know their names? No. Fifth generation also you don't know. Back I'm saying. Fourth, fifth, impossible. But who given that surname? That is also not known. But blindly we are following. Okay, so that is issue. C6S6. What about here? 2 into 6. 2 into 6 plus 2 minus 6 by 2. How much du? 4 pi. 4 pi can I write benzene? Benzene bearing 4 pi? No. Benzene never give 4 pi, only 3 pi. So it is a open chain. 2, 4, 6. Can I put one triple bond? Triple bond and here triple bond. You can write other structures also, but definitely 2 pi bonds are required. So here 2 pi bonds and here also 2 pi bonds. That is the question. So this formula can help in two particular places. One is degree of unsaturation. One more is how many maximum pi bonds you can create for a molecule if you know the molecular formula. If they given one molecular formula, in your interviews they will ask. They will give one molecular formula and they will say, with this molecular formula, how many maximum pi bonds I can create? They will ask. You apply this formula, say, sir, you can create maximum 1 pi bond, 2 pi bond, 4 pi bond, depends on, it is completely depends on which one? This formula. Same, suppose if chlorine, oxygen, nitrogen is there, apply the same formula. Simple. Every halogen is plus 1 hydrogen. Every nitrogen minus 1 hydrogen. Every oxygen, ignore it. Simple. Clear? So that is about calculation of sigma and pi bonds. So in your next class you will see how to calculate lone pairs in a given inorganic molecule. How to calculate a lone pair. So once if you know how to calculate lone pair, then it is very easy to understand Lewis dot structures. Next is Lewis dot structures only. After Lewis dot structures, you will see what is types of fissions. What is homolytic fission, what is heterolytic fission, etc. Then we will see what are reactive intermediates. Okay, carbocation, carbanion, free radical. Okay, so we will give a few selective points regarding to that. Then we will see reactive intermediates separately. There I will explain reactive intermediates preparation, properties, chemical reactions, etc. Then we will see what are inductive, mesomeric and hyperconjugation. That is called electronic displacements. So that we will discuss in your next class. Okay, we'll stop here. Take a break, then sir will continue. So tomorrow we are not conducting any classes. Tomorrow is holiday. So next class after physical chemistry class, next class will be on Monday. Monday same time. Hi sir.